Hello everyone, I'm Douglas Kingscato. Welcome to Java programming class. I would like to extend my heartfelt thanks to Mr. Darlington at Pivosoft Coding Academy for giving me the opportunity to conduct this online session. This course is designed to take you from the basics to advanced concepts in Java programming. We'll cover essential topics including setting up a Java development environment, mastering object-oriented programming principles, handling exceptions gracefully, working with files for input and output operations. Before we dive into writing or running our Java code, we need to access a browser and download the JDK. And this is a website where you can access your JDK, where you can download your JDK. And when downloading, you have to look for JDK 21, the long-term support. So in this case, we'll access it here. And then under Windows or any other platform you're using, you can download the installer file. Okay, and after downloading the installer file, you need to set the path. Okay, and in order to set the path, you have to go to environment, edit environment variable, and under systems, you will select path and click on new so that you can insert a new path. Okay, and in order to access your path, after installing your JDK, you have to access it in the program files. You have to locate where you installed your Java JDK. And then you have to access the bin folder. So you copy this link. This is the link that you copy and add to your path here under system variables. Okay, so it's very essential to set the path because it helps the operating system to locate and run the JDK tools like Java-C and Java from any directory without specifying the full path. Otherwise, if you don't set your JDK path, every time you're running a Java program, you'll be faced with that challenge of setting the path. So it's essential to do it after installing your JDK. So after installing the JDK and setting the path, you have to access your IDE. In this case, you're going to be using Eclipse. Okay. And I hope you're aware Java is a general purpose object-oriented programming language. Yeah, it was developed by Sun Microsystems in 1995 with this initial creation led by James Gosling. So the primary motivation behind this development was to create a platform-independent language suitable for software embedded in various electronic devices. Yeah, it then evolved to become a dominant language for internet applications, renowned for its portability and security features. Yeah, so there's a difference. We have general purpose languages and special purpose languages, and Java is a general purpose language. Yeah, general purpose languages are versatile and can be used for a wide variety of applications. For example, C, C++, C Sharp, Java, Visual Basic, Python, they're all general purpose languages. We also have special purpose, and these are designed for specific types of applications. For example, PHP, Perl, which are commonly used for web development, and SQL for database management. Yeah, so applications of Java, Java can be used in desktop applications like IDEs, like Eclipse. It can be used in web applications, used in systems like online banking, e-commerce platform, and social media sites. For example, frameworks like Spring and Jakarta Enterprise Edition are commonly used. It can also be used in mobile applications, primarily for Android development. Yeah, and some of the features of Java is simple. Okay, it has a straightforward syntax and is familiar, especially for programmers or developers with a background in C or C++. They find Java straightforward and simple. Yeah, it includes the same syntax like the data types, the conditional statements, loops, and functions are all the same. Yeah, and Java is compiled and interpreted. So the Java code is first compiled into bytecode, which is then interpreted by the Java virtual machine, allowing for efficient execution across different platforms. Yeah, Java is object-oriented. Java is based on OOP principles, okay? And OOP or object-oriented programming is a paradigm that organizes code into objects. Yeah, and OOP principles include encapsulation, which involves wrapping data and methods into a single unit called a class. We have inheritance, the ability to create new classes based on existing ones. We have polymorphism. This is the ability for objects to take multiple forms. We have abstraction, which involves hiding implementation details and showing only the functionality. Okay. And another feature of Java is platform independent. Java's write once, run anywhere capability ensures that code can be executed on any device with a compatible Java virtual machine. Java is robust, Java provides exception error handling, reducing the likelihood of crashes due to runtime errors. Java is secure, yeah, due to the Java virtual machine, which runs Java applications. Yeah? It provides a secure environment that is less susceptible to viruses. Also, the last feature is multi-threading. Java supports concurrent execution of tasks, enhancing application performance. Yeah, and Java uses both the compiler and interpreter in its execution process. Yeah, compiler is a program that translates the entire source code of a programming language into machine code. In this case, bytecode in Java before execution. And an interpreter translates and executes code line by line, okay, at runtime. Now, the Java virtual machine acts as an interpreter, reading bytecode and converting it into machine-specific code, okay. Yeah, the Java virtual machine is responsible for executing the bytecode and provides a runtime environment in which Java applications can run regardless of the underlying operating system or hardware. Okay. Yeah, so we are going to create a very fast Java program. So in case you are new to Eclipse, you can find it. You can just click here, create Java project, or you can go to file, go to new, then select Java project. In this case, you can give it can give your Java project a name, Java. You can specify, in case you don't want to use the default location to save, you can specify, you can go to browse where you want to save your Java work. Okay, in this case, I'll select this folder here for Java. Okay, or even I can create a new one. Just call it online. Select that online folder. Make sure it's selected. All right. After confirming, you can go to next and read through, and then you click on finish. Okay. Yes. Now after that, you can access your source. Right click on your source folder, then you choose a new class. You're going to name this class Hello World. And when you're naming classes, you have to start with a capital letter. Hello World. You have to choose this public static void main, and then you click on finish. Okay. It shows something here. Oh, sorry. Okay, let's first create a package. Page. I work. Finish. Now, right click on your package. Go to class. Give it a name. Hello World. Right. Choose this option. Public static void main. Finish. All right. We have our first Java class here. Okay. So what I'm going to do, I'm going to highlight this comment. Then I'm going to type system because I want to print my string system dot out dot print line. All right. And terminate. So inside here, I'm going to add my string, hello world. All right. Now let's try to run it and see. Yes. Now I hope you can see my console here. It says hello world. So this is the very first Java program that we have created. So if I'm to talk about this, a package is a code library that has a combination of classes, interfaces, and sub packages. Yeah. So I created one because I wanted to add my class in there. I wanted to because a package in this case is going to act as a directory or folder where I can store all my files. Okay, in this case, I have a class called Hello World and I want to save it there. Okay, and the name, I hope you can see it. My work. Okay, so we created a class here. called hello world, and it's public. Public is an access modifier. Okay, and we also have our main method here. Okay, this is the main entry of our program. And we also have an access modifier here called public. Public is a keyword. It's an access modifier that makes the class accessible from anywhere in the program. Okay. We have static. Static. The main method is static, meaning it belongs to a class rather than an instance of the class. So this allows the Java virtual machine to call it without creating an object. Okay. Yeah. So we have void. Okay. And void, basically the method does not return any value. So that's why we use void, because we are not going to return anything. Okay. And we have main. And the main method is the entry point of our Java program. So in here we have system.out.println, and inside it we pass a string called hello world. Yeah, so system is it's a predefined class in Java that provides access to system resources like input, output system. We have this out. Out is a static member of the system class, okay, representing the standard output stream. And println, this method, uh, this is a method of the print stream class. Okay, it prints the line of the text to the console. Okay, so basically this helped us print our message to the console. Yeah. Okay. So after that, I think we're going to move to our next topic, which is data type. And for that, you need to create another class. So right click on our package, and then create a class, and you're going to provide a name. Maybe you can call it variables. Variables. Since you're going to be discussing about data types, you can do it in variables. Okay. Finish. Okay, then we double click on our class, which is here. Okay, selected. So in here, we're going to first of all, anyway, before we move to coding here, a data type is an entity used to describe the kind of data to be stored in a given variable. Okay, they can be primitive or reference data types. And in this case, let's first list them down anyway. So here I'm going to say primitive data types. Primitive. Okay, data types. Enter. So in here, we're going to declare a few. We're going to use int age, or maybe 25, terminate, double. These are all data types, the ones I'm mentioning here. Salary. Okay, maybe you can say 5,000.05, terminate. We have character, grade, maybe you can give it A. Terminate. We have boolean. We have a fun. True. Terminate. Can have a float. We have like 8 data types, at least in Java. So let me see: int, double, character, boolean, float. Which other one can I add here? Okay, for now let's use this. It's okay. Oh yeah, we can add byte. Yeah. A minute. Okay. So a byte is used to save memory in large arrays. Okay. Having a size of 8 bits, 1 byte, and it ranges from -1 to 8 to 127. We also have short. Okay. Maybe we can say short s equal to 100 also. Terminate, space it here. Right. Yes. Okay. So short, it has a size of 16 bits, basically 2 bytes. Okay. And we have int. Int is used on whole numbers. having a size of 32 bits or 4 bytes. Okay. We also have long. Let me add long. Okay. Now long is used on large whole numbers. Yeah, it has a size of 64 bits, 8 bytes. For float, float is a floating point decimal. It's used on decimal numbers. Okay. It has a size of 32 bits, 4 bytes. Okay. Double has 64 bits, 8 bytes, and characters 2 bytes. Okay. It's used on single characters, as you can see. It's good for defining symbols. Okay. So we have Boolean, and Boolean usually equates to true or false. It's used in conditions or flags. Okay. Yeah. And control flow statements. Okay. So these are your basic primitive data types. You have int, you have double, character, boolean, float, byte, short, and long. Okay. Now, if you are to move along, we also have reference data types, but I don't think I will discuss those right now. Yeah, maybe they'll come in the later chapter. For now, maybe what you can do, we can first look at the control flow structures before we continue, before we talk about the reference data types. So with the control flow structures, we can right click and create a new class. We can name it control structure, control structures, control structures. Okay, select this. Okay, finish. Yes, you have a control structures. Okay, so we are going to look at the different, control flow structures. We have the if else. Maybe you can start with the if actually. Let's say if you define here int number equal 10, terminate, right? Enter. So we are going to use it in an if else statement. Let me label it if else statement. Enter. Here you can say if number greater than 0. Let's space it a bit. If okay, basically you're saying if our number is greater than 0, we want something to happen in case the number is greater than 0. So here you can say system will print line, terminate. You're going to pass our message here. You're going to pass it as a string. So you can say number is positive. Right? You can say number is positive. Right? Okay. Else if number is less than 0. Now what will come next? Let me copy this line. Of course, we say the number is negative. All right. And then we have else. Number is 0. Okay. So this is our very first control flow statement, if else. So you are saying if a number is greater than 0, number is positive. If it's less than 0, it's negative. Else the number is 0. So let's first run our program. You see. So since we declared here and assigned a variable 10, 10 is greater than 0. That's why you're getting number is positive. In case it was minus 1, okay, let's run it. You see, it shows the number is negative. How about if it's 0? Number is 0. Okay, so let's run back to our default tab. So this is how your if else statement works. Okay, now if you are to look at the if you have to look at the loop, maybe we can start with the for loop. For loop, all right. Yeah, we can say system. Actually, let me copy this line. We want to do it again. Okay. And in here, I can say counting from 1 to 0, 1 to 5. Okay. Say counting, counting, counting down from 1 to 5. Okay. And then you're going to declare int count. We're going to assign 5 to it. A minute. So you're declaring a variable and assigning a value to it. Okay. Actually, we don't need to declare it yet. Let's just go to our for loop immediately. You can say for. Now for the int, we have to pass in, because it has the you have to declare it like this. Okay, we have to create a for loop like this, a for loop like this. You have to say int I equal to 1. All right, space it a bit. I equal to 1. Terminate. I less than equal. I less than equal to let's say 5, since we're counting down from 5. Terminate. I plus plus. All right, and then system.out, you're going to print. I copy this. Instead of passing this, I'm going to say, I'm going to highlight everything, put I. All right, let's first print to see the output. So you can see it's counting down from 1 to 5. Yeah. Okay. So ignore the first one, number is positive. This is for the if else statement, but you can look out for counting down from 1 to 5. So that's how a for loop works. Okay. Now if you are to look at the while loop, yeah, while loop. Maybe I can copy this. Paste it here. Actually, this was supposed to be counting up. So this is counting down. Okay, enter. So for while loop, we'll declare a variable count and assign it 5. Then while count 0, we'll print this one. This case we're going to be printing count. Okay, and then we can say count minus minus terminate. Okay, let's run it to see. Yeah, so here we have our if else statement, number is positive, and we have our for loop that's counting up 1 to 5, and also we have our while loop that's counting down 5 to 1. Okay, so this is pretty much it. The control statements, there are many, but because it's do while, yeah, but for now, if statement and for loop and while loop, okay. Yeah, so now you're going to move to typecasting. Yeah, now typecasting is a process. It's a process of converting one data type to another, and there are two types of typecasting. We have implicit casting, widening. So this is automatically done by the compiler when converting a smaller data type to a larger one. For example, into double. We also have explicit casting, narrowing, This is manually done by the programmer when converting a larger data type to a smaller one, for example, double to int. And to demonstrate this, you're going to create another class. Okay, right click, we create another class. For this one, you're going to name it typecasting. Casting, choose this, finish. Okay, of this, delete, delete. Okay. So inside here, we're going to first create implicit casting. Okay, and in order to do that, you're going to create int, my int, assign it 10. Okay, so you're declaring an integer variable and assigning it 10. All right, after that, we'll create a double, call it my double. We're going to assign it to my int. Right, and then we terminate. So what you're doing here, we are automatically converting into double, okay, and there's no data loss. All right, then you're going to print system dot out dot print terminate. All right, and you're going to first pass a string. You're going to say implicit casting semi double. Let's see what the result will be. So if you are to run this, let's see what it will give us. So here it's saying implicit casting is 10.0. Yeah, which is okay. There's no data loss. Okay. Now let's look at explicit. Now for explicit, let me first create a comment. Right. So for it, you're going to start with a double. Maybe I call it double D. D 10 per minute. Right. Then you can int, maybe I call it C. Plus int, bracket, then C per minute. So here we're manually converting a double to an int. Okay. Yes, and the decimal part is going to be lost. Okay. Yeah, because there's no precision when you're doing explicit. Yeah, there's no precision. Data is lost. All right. So I'm going to print. Let me first copy this. Change this to explicit. And then here, you see, right. Oh, this was supposed to be D. So D and also here D. Confuse them. Okay, let's print. You see. Yeah. So we have implicit. Implicit is 10.0. And for explicit, you have 10.1. So the 0 got lost. Okay, it was truncated. Yeah, so that's a major difference between implicit and explicit. Yeah, one is automatically done by the compiler, explicit is done manually by the programmer. There's data loss. Okay, now after looking at this, we can look at wrapper classes. Yeah, and wrapper classes are used to convert primitive data types into objects. Yeah, each primitive data type has a corresponding wrapper class. Let's create a class here, new class, and call it wrapper class. Wrapper class. Okay, finish. All right. Now in here, All right. So as I was saying, each primitive data type has a corresponding wrapper class. Let's say int. Yeah, it has a corresponding wrapper class integer, but it starts with a capital I. Same with double. Double has a corresponding wrapper class double starts with capital D. Okay, that's how it goes, right? And with wrapper classes, they are useful in scenarios where objects are required, such as in collections, like array lists. Okay, and we have autoboxing. Yeah, autoboxing involves automatic conversion of a primitive data type to its corresponding wrapper class. For example, int to integer. This up here. Okay. We also have unboxing. Unboxing, it's automatic conversion of a wrapper class object to its corresponding primitive. Let's say integer to int. Yeah, that's unboxing. Automatic conversion of a wrapper class object to its corresponding primitive. Integer to int. Okay. We also have utility methods. These are wrapper classes that provide useful methods like integer.parseInt, double.toString, for converting between types. Okay. And inside our class, the one we created right now, I'm going to add a comment. Um, can say converting um, primitive, converting primitive to object, which we acknowledge as autoboxing, right? Autoboxing, yes. Enter. So for it, you're going to say int uh, primitive int. You assign it 42 a minute, right? And then you say integer with a capital I, wrapper int. All right, so you're going to pass our primitive int to we're going to pass our primitive int to this. I forgot the assignment operator. Sorry. Yeah, I'm going to pass this primitive into our wrapper int, right? Main system. So here you can say primitive to wrapper. Also, this and space here. Call back our wrapper int. We're going to call back this. We can copy it from here. Right. Let's first run it to see what the response will be. Yeah. So you have a successful conversion from primitive to wrapper. It's 42. Okay. So now let's go to the second one, autoboxing. For it, you can say converting object. Previously, we were converting primitive to object, but since we are unboxing, I'm going to convert object to primitive. All right. Now for this, for unboxing, we will start with a double and a capital D. All right. Terminate, double with small b. Then I can say primitive double. Okay. Terminate. Yeah. So now we are unboxing this line here. We are unboxing. Okay. Yeah. we're unboxing this double to this double. All right. So let's print. Let me copy this line here. In this case, we're going to switch. And say wrapper to primitive. Right. Wrapper to primitive, and inside here we'll pass primitive double. We can copy it from here. Primitive double. Primitive double. Here. Okay, let's first run it to see if we have any issues. No issues. So we successfully unboxed. At first we auto boxed, and now we successfully unboxed. Okay, yeah. So let's see how we can use wrapper classes with methods actually. Yeah. Our next example will be using wrapper classes with methods. Okay, for it to create a string, capital S, number, right? And you can say strings are passed in double quotes. Okay, then you can say int integer dot. Immediately put that dot, integer dot. You can see we get some options. Okay, and in this case we are looking for pass int. All right, pass int, and inside here we have to add the number. This one here, number str. Okay, after that we terminate. So here we are converting a string to integer. All right, let me add a comment. Converting string to int. All right, yeah, and then you're going to print and see our output. Let me copy this. Now in here set past as integer, right? Let's run it to see. Yeah, so we successfully passed this string here in double quotes. We successfully converted it to an integer. Okay, yeah. Also we can use wrapper classes in collections like array lists. Let's see if we can do an example here, because we talked about it earlier. Using wrapper classes in collections. Yeah, in this case array lists. Okay, and for that one we can either import the java.util array list, or we can just specify it here. Let me specify it here, java, but usually it's imported the util because this is a package for us to access our array list. Dot array with a capital A. I've never tried this. Usually I would import, but let me try it and see. So in here I'm going to pass integer. Okay, right, for new java util dot array terminate. So you're creating an array list of integer. All right. And now what you're going to do, you're going to add integer objects to the list. And how can we do that? You can do that by saying numbers calling back that numbers list dot add. See, we have it here dot add. Let's select the first option. Maybe here you can pass 20. Okay, terminate, enter numbers list dot gain. Here we can pass like 10. Okay, I'm going to terminate. Then I'll print. Let me copy this. Right now here, in case you're printing, what you're going to do, you're going to print array list. Number list. Okay, number list here. Numbers list, sorry. Numbers list, okay. Yeah, so let's try to run our program. We see what you get. Yes, so we're able to create an array list. I hope you can see it here. Okay. Yeah, we're able to create an array list. Yeah, now after this, you're going to go back to our, remember when we were discussing data types earlier on, we said there are two types of data types. Primitive, we looked at primitive data types. And by the primitive data types, they are the built-in data types representing a single value and are not objects. They include byte, short, int, long, float, double, character, boolean. Okay. Now we are going to move to reference data types. Reference data types are non-primitive data types that store references to memory locations where the actual data is stored. Yeah, they can hold complex data structures and represent multiple values. They include classes, arrays, interfaces, strings, and enums or enumerators. All right. And the key characteristics of reference data types, they point to memory location where the actual data is stored. They can hold multiple values and support dynamic behavior. And they are stored in the heap memory. Yeah, they're stored in the heap memory. Yeah, while reference variables are stored in stack memory. So we can begin with a class. A class is a blueprint for creating objects. It defines properties, which are fields, and behaviors, which are methods. Okay? And the reasons why class is a reference data type is that objects of a class are stored in the heap memory. That's one. And the variable holding the objects stores the memory address of the object. That's two. And classes can encapsulate complex data structures and behavior. So those 3 points make class a reference data type. And maybe you can experience this by creating a new class. You can create it inside here, our package. You can go to file, new, and then look for class. And maybe you can call this class student. So capital S, student. Yeah, we have this, finish. Right, now in here, first of all, we are going to create a string, name, terminate, int, age, terminate, int, age, terminate. Actually, let's do this. I'm going to create them here. What you're going to do is this. It's okay. I'm going to remove this. Not yet. We don't need this method yet. So it's a string name, terminate, int age, terminate. All right. We're going to first create a constructor. Yeah, we're going to look at constructors later on, but they're used to initialize objects. Okay. I'm going to create a constructor here. And constructor is a special class. It has the same name as a class. So since our class is student, also our constructor should be student, okay? And this is going to be a parameterized constructor. Parameters, yeah, string name. We're going to use this keyword. Let's access the name. Was name. A minute. Enter this keyword again. Age. Age. A minute. Don't worry, we're going to look at constructors down the line, but now I just want to show you an example of a class and how it can be used. Okay. So we're going to create a method. Going to create a method to display student details, right? And here, since we don't want our method to return anything, we can use void display. Void display, and we can print something like system dot out dot print. Inside our outputs, we can pass name, right? Name, right? Concatenate to this name, then and we can pass age, right? Yeah, I think that's it for this class. Okay. So we're going to create another class, the main method. We are going to be calling this. Right click here. We can give this main. Right. So this. Okay. And in here, we're going to create an object of a class. Let's see, create an object of the student class. Here you can say student, student, and call this student Florence, and I can pass 20 for the age. Then I terminate, and I want to display student details. Right here, I can say student dot, and then I look for that method we created, which is void. All right. Yeah. Let me first run this to see what it will give us. Yeah, it's giving us Florence, age 20. Name is Florence, age is 20. Okay. Yeah. Now let's create another object out of this anyway. Go down here and create one more object. And student, can say student 2. Right. Terminate. Maybe I can say Douglas. Put them on. and comma, give person age like 15. Yeah, then I say student 2 dot. Okay, let me run it. I see. Yeah, so you have a second student here. We have Florence, age 20, Damian, age 15. So you can continue creating multiple students if you want. Yeah, and then in case you want to modify the first student or anything else, maybe add a new name. Let me call this modify. Maybe you can say modify student's name. Okay, and then we display it again. I can just copy this first student. Is this one? Copy this information here, paste it here, access the tab, right? But in this case, I didn't need this line. What I could do, I could just say student, right? Student dot name, can access it here actually. Dot name, student dot name. Then maybe I can say Namatov and terminate. All right. Then we can add this. Can add another printing line system without the print line. Terminate. All right. In here we can say after modification, it's gonna escape sequence. Right. Let me run it. I see. So previously, student, the first student we created was Florence, age 20. And then we created another student, Damian, age 15. So we modified the first student to Namatov, and you can see the modifications here. Yeah. So basically, that's a class. That's how our class is done. We have been creating classes actually, yeah, since the start of this program. Okay. Yeah. So both student one and both student 2 and student, okay, refer to the same object in memory. Yeah, okay. And the changes made can affect the other. So anyway, as I said earlier, constructor is a special method used to initialize objects. It's called when an object is created using the new keyword. And also this keyword, because initially we created a constructor here, and I told you that was used to initialize objects. So we have this is a keyword, yeah. It refers to the current object and is used to distinguish between instance variables and parameters. Yeah, so we look at that when we reach constructors in particular. Okay. Yeah. So yeah, this is basically it about classes. Yeah. So all you need to know is class is a blueprint for creating objects, and you should know this. All Java programs are classes. Okay. Yeah. So we're going to move to our next reference data type, which is arrays. And an array is a collection of elements of the same data type stored in a contiguous memory location. Yeah, arrays are static data structures, meaning their size is fixed at the time of the declaration and cannot be changed afterwards. Yeah, elements are accessed using zero-based indexing. I hope you know that. Okay, and we have two types of arrays. We have single-dimensional arrays, which is a linear collection of elements. We have multi-dimensional arrays, basically an array within or an array of arrays, mostly 2D arrays. Okay, and let's create a class, yeah, where I can show this, where I can show how we can create arrays and all that. Yeah, let's create a class. We can call it array main. Anyway, to click here. Java new Java, create a class and say main array or something. Anyway, what can I call it? Example array. Example array. Okay. We add this. Finish. So we're going to start by creating a single dimensional array. Single dimensional array. All right, and we can first print it out so that we know the difference. System dot out will print in here. We can say single dimension. Right, yeah. And one of declaring arrays, actually you have multiple ways of declaring arrays, but in this case let's stick to this int square brackets. Right, then we provide a name, numbers equal to new int, and we're going to assign a value to it. In this case we'll set 5, and then we terminate. Right, so we have an array of size 5 here. So you're going to add information to it. You can say numbers, right, at index 0, maybe you can say equal 10, terminate. We do the same thing, numbers here 1, 20, terminate. I forgot to add the equal sign. All right, yeah, I think these ones will be enough. So let's see how we can access arrays. So here I have declared and initialized, yeah, an array of size 5. So let's see how we can access it. You can use by system.out. Let me copy this line. Now in here we can say element or element. Right, and here we concatenate numbers past 0. All right, so you can duplicate this line and print both numbers if you want, and then change the index for this one to 1. All right, so let's first print it out to see how it looks. So yeah, that's our single dimensional array. We have 10. Oh, here I messed up. It was supposed to be 1. Yes. Yeah, index 0 we have 10, and index 1 you have 20. Okay, so that's pretty much it for what, for single dimensional arrays. Yeah, also arrays can be used in loops, by the way. Yeah, you can print all elements using a loop. Let's see how, if we can do it here. Let me copy this first. Maybe I can say all elements in an array. All elements in an array. So I'm going to use a for loop. In here we can say int I equal to 0, terminate. I can say less than number dot length, numbers dot length. All right, we terminate, we say I plus plus. All right, now inside our loop we're going to print, copy this, we can change this elements at index, and then we right, and this, right, I can say change this to I. Okay, let's see how it works out. Yep. Hope you can see the difference. Let me add another system dot out so to space it. Right, let's run it to see. Yeah, the space, so you can see. Since we assigned an array of 5, you can see from 0, 1, 2, 3, there are 5. But since we didn't assign 2, 3, and 4, they have come back as 0. Alright, so let's look at multidimensional arrays now. Okay, yes, after doing that, we can create our array. Right, since we're going to be using a two-dimensional array, yeah, we will need two square brackets, okay? Call it matrix, new, so 2, 3, okay? Yeah, so you have a 3 by 3 matrix here. Terminate. Okay. And thus, you are going to assign to it matrix 0, 0. Yeah, you can say, and do one, but maybe you can say 1, maybe I can say 2. Yeah, you can leave 1, 1, doesn't matter. So you're going to print find it. So here I'm going to say elements over 2D array. Okay, and in here we can use matrix to length instead of numbers. All right. Okay, and in here you can add another loop, a nested for loop. The other one was int I, so this will be j. Right. In here you're going to print system.out. All right, and I'm going to print matrix. Just it a bit. Yeah, we terminate. Then you can add yeah, remove. So this one moves to the next row. Okay. Yeah, let's first run it to see how it works. So see something is wrong, and then I need to add this system without here. Just let me copy these, duplicate them some more. Let me duplicate these. Maybe this can be 10, 11, 12. This one can become 20. This one becomes 2. This one becomes 21. Okay, first one to see what it gives us. Yeah, so you see our output down here. So they're all here. So that's it with arrays. Yeah, we have multi-dimensional arrays and single-dimensional arrays. Okay. So now we're going to move on to interfaces. Now, an interface is a special class. An interface is a special class that contains methods without the body or implementation details. They are abstract methods that can be implemented and are used to specify a contract that a class must follow. Yes, a class can implement multiple interfaces, enabling multiple inheritance in Java. And interfaces enable polymorphism by allowing objects to take on many forms or multiple forms. And we can start by creating a Java project. I don't think I'll create a Java project. Okay, let me see why. Let me just create another package. I don't need another Java project. Let me just create a package. Maybe I can call it, the name for a package, I'll call it maybe com.animals, right? Finish. Once I do com.animals, I'm going to create my very first class, okay? And my first, actually, not a class, I'm going to create an interface, since we are talking about interfaces. Yes, I'm going to create my very first interface, and the name for this interface, I'm going to call it animal, all right? The animal interface, okay? Yep, you can click on finish. Now, you don't want an interface public. Let's remove this public access modifier. Right, to just have our interface animal. So this interface animal defines the animal interface. And inside this interface, we're going to create an abstract method with no implementation, which will be void. Next sound. All right. And what you're going to do, we are going to implement. We are going to implement. We're going to create a new class and implement this interface for animal. And by that, you're going to right click again here. Then we create this time around. You're going to create a class. We're going to call this class dog. Yeah, again, this class, you don't need this public access modifier. So this dog is going to implement When you're working with interfaces are implemented, classes are extended. So we're going to implement that interface animal, called animal. Inside it, you're going to provide the implementation for make sound method. In this case, we can say public void make sound. In this case, we'll say system print line. Okay, so we have implemented our. Remember here, our method was abstract with no implementation. So we created a class dog where we are implementing that abstract class, and we added a something to our abstract class, our abstract method rather. Sorry. So what you're going to do, we're going to create another class. Actually, you could create multiple classes for cat, or even birds, anything you want. But in this case, one class for dog will be enough. Then you create another class inside this package. The same, we'll call it main. Okay, now inside here, we're going to create objects. Let's comment it out. Okay, you can say animal. We're going to call the method the make sound method. And set dog dot sorry, small dog. Yeah. And set dog dot, we'll look for our method make sound. All right. Yeah. Let's try to see. Yeah, wolf. Okay. So that's it with interfaces. Okay, interfaces, they work with abstract methods implemented in the class. Okay. Yeah. Now let's move to our next one. We have strings as a reference data type. So far we have looked at class as a reference data type, arrays, interfaces. Now we're going to go to strings. A string is also a reference data type. A string is a special reference data type that represents an immutable sequence of characters. It behaves like a primitive type for text storage, but is an object with methods for manipulation. Okay, once a string object is created, this value cannot be changed. Any modification creates a new string object. Okay, and string variables store reference to the memory location where the string object is stored. Yeah, string class provides various methods for string manipulations like to, uppercase, or length. Okay, now let's create a new. We're just going to create a new class. Let's go back to my work. For this one, just create a new class. Okay, and maybe we can call this class example. Maybe example string. Now I can add this public. Finish. Yeah, so now you're going to first create a what? You're going to create a string object. Create a string object. All right. Now in here, we're going to declare a string name, Douglas. Okay, we'll terminate. Okay. Now here we have a reference. This is a reference to a string object in memory. It's a reference to a string object in memory. All right. What's this is? Right. Yeah. Now we're going to print because we're going to make modification to the string. We're going to first print the very first original string, and you can do that by system. In this case, you can say original string. So we're going to make modifications to it. That's why I'm printing this line. We're going to have our original string here. So we're going to create another string. This time we're going to say modified name. We're going to modify this. And immediately when I press the dot, you can see you can access some methods here. But in this case, we want the two. Let's choose two uppercase. Yes, two uppercase. Okay, we'll terminate. All right. Then you're going to print this again. Let me copy this line. In this case, you're going to say modified name or modified string. We choose modified string, and then here we'll give modified name. Okay, modified name. All right. So we can first print this to see the difference. Maybe before I print it, let me add a system.out dot spacing. Yeah, you can see this is our original string, Douglas. Okay, it's in sentence case, I should say. Now our modified one, we change it to capital letters, and you can see the change. So this makes strings a what? It makes it a reference data type. Now let's see one other example we can work with. So maybe we can comment this and call this modifying a string or something. Let me see strings. What can we call it? Okay, let me just leave it. I think you understood the example. Let's go to the next one. So here we're going to let me see what else can we do with strings. Let's demonstrate how it is an object. Let's demonstrate how string methods. Let's demonstrate string methods being an object. Let's see. Let me create a system. Let me copy this actually. Let us see. Okay. So we're going to say length. Length. M dot. Okay. So want to find the length. Let's run it to see. If I let me add spacing. Let me run it one more time. Yeah, so you can see they're saying the length of the string 7. Okay. Now after strings, you're going to look at enum, and enum is going to be our last reference data type. Okay. So enum is a special reference data type that represents a collection of predefined constants. Okay, it's used to define a fixed set of values, improving code readability and type safety. Okay. Characteristics of enums. Enums define a set of named constants. For example, Sunday, Monday. Enums ensure valid values are being okay. Enums enable type safety, which is essential. Invalidating values. Enums can have methods, fields, and constructors, making them more powerful and simple constants. And okay, let's create another package. Oh, class. Let's just create another class and name it enum. Can go to my work package, go to class, give it a name, maybe my enum. All right, finish. Now in here, we are going to first define our enum up here. And we can do that by using this keyword enum day. All right, going to pass in the days of the week from Monday to enter and say Monday, and they have to be in capital letters since they are constants. All constants have to be in capital letters. Don't need to list all of them. I guess you get the point. Yeah, that's how we do them. Okay, and then we come inside our main class. Let's see how we can use enums. You can say day today. We can say day dot. And say today is Friday. Yeah, today is Friday. We terminate. Now we are going to use our switch statement. Switch is another control flow structure. Switch. Okay, works as if else. It's a better version of if else. Right? Start by case. You can say case Monday. Like this. And, say system. So today, Monday. Then we break. So I'm going to copy this line. Change this to Tuesday. So Thursday, Friday. Just to be in capital Friday. Okay, even here we change it to Friday. We'll choose a default. So default system. Let's copy this. Okay, let's just type it system out valid day. Okay. Also, we need to break. When you're working with a switch, you have to break so that you jump out of that loop. Okay. Um, let's run it. You see. Oh, sorry, forgot this. Yeah, today is Friday. Yeah, because today is Friday. Let's assume it's Sunday. Okay. Oh, sorry. This dot. Okay, let's assume it's Saturday. Okay, let's try to see. Today that actually showing a valid day. Yeah, and it's showing a valid day because I didn't add a case for Saturday here or Sunday. Let's say okay, let's choose Friday. Oh no, maybe Monday. But Monday and yeah, and says today is Monday. So Saturday and Sunday are not working. They are showing a valid day because we didn't specify them here. Okay. Yeah. So that's your enum. But I also want I also want you guys to know that enums can also have fields. You know methods, fields, methods, and constructors. Yeah, you can use fields, methods, constructors. Yeah, with enums. All right. Um, see, can we do it? Let me see if I can refactor this code and show you what I mean. Hmm, okay, let's see. Let's see what you can do. Sunday. So in brackets, you're going to say Sunday is a weekend. Weekend. Same will apply to Saturday. Saturday is also a weekend, and they should be in quotes actually. Going to duplicate this and we change it later. Let me first change one. So these are weekdays. Friday, same here, weekday. So weekday, weekday. Okay. Enum day. Okay. Okay. So what you're going to do is this. You're going to try and add a private string type or the constructor set day bracket string type. Alright, string type. Remember constructor is used to initialize objects. So you can set this dot We access type, equal type, right? We terminate. So I'm going to create a method. I'm going to create a method. This method will be public, and it will return a string. Say get type. Okay, terminate. Okay. After that, we go to our main class. All right. This time around, we remove the switch. So today is Friday, so let me change this to Friday. Friday. And print this out system out print line and set today is want to access our method, which is here get type. Let's terminate to run our program, see if it works out. Yeah, today is Friday, which is a weekday. Yes. So enums can also have fields and methods, and we can use constructors just as I've proved here. Okay, we have our constructor here, we have our method here, and we're able to call it in the main method. And the output is today is Friday, which is a weekday. Yeah, let's assume, anyway, I didn't do for Saturday and Sunday, so let me see if I can change to each other day. Okay, let me choose Saturday. Let's run it to see. Yeah, today is Saturday, which is a weekend. Yes, so it still works. Okay, all right. Now, I want to just talk about records. Well, I don't know if we'll be able to use them, but record is another special kind of class in Java designed to hold immutable data. So with a record, it automatically generates a constructor, getters for all fields, equal method, hashcode method, and toString method. Okay. Yes, and records are ideal for data carrier classes where the primary purpose is to store data. So maybe what we can do, we can create a class. Let's create another class here in my work package, and then I can call this maybe my record or my records. So like this, add this method, finish. All right, and inside it we can create okay, my records. Let me see. Should we create a package like the way we did with the interface? Okay, let me remove this. I don't need it. Okay. Alright, so what you're going to do, let's create a package. Let's right click on our source to create a package. And what name can we give it? Can we give it? Okay, let me call it com. Good. Or maybe let me call it Douglas. Finish. Inside this Douglas, I can right click on it, go, um, person. Okay, that's it. Right, finish. Okay. Um, so inside here, um, see, this can be a class. Let's see if I can manually convert it to a record. So there's an error. Let's see. It's showing an error. Space. Some of it. Project clips. Project clips is supposed to give me that. Let me right click. Oh yeah, record. Sorry about that. I was supposed to use record. Let me call it person. I was using a class instead of a record. Mm, okay, let me add this method here. Good. Yeah, this is what I wanted. So we have our record here. Okay. Maybe inside this record, let's see. Can we pass in parameters? How should we do it? Okay, let me pass in parameters here. Can say string, the string name, comma, in age. Okay. Okay. So we don't need to create the getters and setters. Yeah, they automatically be generated for us. Okay. So in our main method, let's see if we can call it back. Let's see first if we can create. We need to create an instance. Person record. And we can do that by saying person, person, new person, uh, can say Florence, and I can pass the age as 22. Terminate, right? Let's see how we can access. So I can access record component. Okay, let me see system dot out dot print can say name person dot name. Okay, you can copy this line. Age. Oh, we're supposed to get method for name. Here's a method for name. Here's a method for name. Yeah. Okay. Okay. And while we're at it, we can automatically generate a toString method in case we want to. Let's copy this. So to run the program at once when you're done. Here we can say personal details. or person details, or maybe person. Then you can just say person, right? And if you want, okay, let's just 1 minute to see how it is. Yeah, you see, we're able to create a record person without adding constructors and getters and setters. Yeah, so that's one essence of a record. A record helps us a lot. Yeah, it creates immutable data and it automatically generates a constructor, getter, echo method, hashcode method, and toString method. Okay, so we're able to generate this information without specifying them inside the record. Yeah, so what else can we do? Can we anyway? Let me show you how we can use the echo method actually before we finish up. Before we wrap up, let me copy this. We see how we can include the hash code and the echo method. So for the echo method, can maybe ask a question: are the persons equal? And then maybe here you can say maybe persons dot. Then we access that equal, which is here. All right. Now inside, um, actually, we need to first declare another person. Yeah, we need to first declare another person. Let me first copy this line here. Control C, Control V. This one maybe I can call it person one. Person one. Okay. Now this. So here, I'm going to pass in person one. Right. So we want to see if both records are equal. Okay. If the people in the record are equal. Okay. Let me run it and see. Yeah, it says are the persons equal? It's bringing back true. Okay, if they are not equal, it will bring back false. But now it's bringing back true since both persons are equal. Let's come and let's try when they're not. You see what it does. Because they are not equal. Let's see what the output is. Program it in a minute. Yeah, in case I'm to change this to Jim, then maybe I can put like 12. Let's run it to see. Yeah, nice bringing back false. Yeah, so that's the echo method. Let's try hash code. You see what it will bring. Copy this line, right? Let's look for the hash code. Sheet. Here it is. Okay, let's run it to see what it will give us. So this is the hash code for the person. Okay, so that's it about records. Okay, it's an interesting one. Yeah, it simplifies work for us. Okay, what else can we look at? Oh, yeah, let's look at exceptions, I think. Yeah. So exception handling in Java. Yeah, exception handling is used to manage runtime errors. And let's see how we can implement it in Java. So what you're going to do, we're going to create a class under my work, new class. Okay, and maybe you can call it main exception. Main exception. Okay, at this, finish. So exception handling is used to manage runtime errors. And we can do that through the try, catch, and finally. Okay, the blocks. Let's first list them down here. We'll see what we mean. Try. Here we're going to say something. Let's say int result equal to 10 divided by 0. A minute. All right. System dot out dot print line. Here you can say result. Result. Okay, terminate. Result. Okay. Now try the catch. Catch. And once you declare catch, you need to pass this arithmetic exception. We need to pass this catch arithmetic expression E. Then you come back in here. We print system. Let's copy this. But in this case, we'll say cannot divide by 0. Cannot divide by 0. Okay. Yeah. And then we can do our final here. Finally. This line. Web always executes. Okay, let's first run it to see. Yeah, so you can see. Yeah, this is how we can anticipate and try to mitigate exceptions. Yeah, through this. Since we can't divide by 0, it gave us the catch. We expected to get an error here, so we decided to mitigate it with a catch. That's why it's saying cannot divide by 0. And this finally, it always executes. Yeah. Okay, so that's exception handling. So try contains code that might throw an exception. Catch handles exception if it occurs. And finally, contains code that always executes whether an exception occurs or not. Okay, and the types of exceptions include checked exceptions, must be handled at compile time. For example, input output exceptions. We have unchecked exceptions occur at runtime. For example, arithmetic exception and now pointer exception. Okay, you can also have multiple catch blocks to handle different types of what? Different types of exceptions. Okay, let's see if we can modify this to show that you can create an array. You can convert this into an array. Then you can change this maybe to numbers. All right. Okay, 1, 2, 3. That's okay. Here you can change this to numbers. In here you can pass like 5. Okay, and then we can introduce that. Right. So here we are going to change this arithmetic We are going to change it to array index out of out of bounds exception. And here we'll change this and then we can also add the exception back. Actually, since we are doing multiple catch, shouldn't have deleted it, but it's okay. We can always do it again. Catch. Forgot that we're doing multiple exception, multiple catch. Um, okay, in case you have to run this, maybe we can change it to this to this. We can say this always executes. Yeah, it's okay. Let's run it to see what it gives us. Yeah, array out of bounds. So it executes. So you can see you can use multiple catches. You can use a multiple catch block to handle different types of what? Of exception. Okay. Now we're going to move to file handling. File handling involves reading from and writing to files. Okay. And we can do that by creating another class here. Uh, New class. You can call it my files. Okay. Finish. Yeah. Now, before using this, we need to import some packages, okay? Go here, we add import java.io dot file. We're looking for file writer, which is this one here, I assume. Okay, then we add another import java.io dot. Okay, now we can start, right? So we will need another try and catch. Let's go here, can say try. Maybe you can say file writer equal to new, creating basically creating a file writer object, right, to a file named file.txt. Yeah, you can say file writer equal to new file. And in here we're going to pass our file we want to write to, which is file.txt. All right, we'll terminate. Then we say writer dot write, and see it here. Writer dot write. Writer dot write, you can pass here maybe hello Douglas. Okay, writer dot write hello Douglas, and then we have to close the writer. It's important that you close to avoid memory leaks and all. Okay. After that, you're going to print. I'm going to do that by system get out your print. After this try, we need to add a catch. We need to use this print stuff trace. Okay, let's first run it to see how it does. Oh, yes, it's a success. Successfully went to the file. Okay, yeah, so that's file handling involving reading from and writing to files. Okay, yeah. As I promised talk about constructors. Yeah, constructor is a special method used to initialize objects. As we saw above there, it's called when an object of a class is created using the new keyword. So constructors have the same name as a class and do not have a return type. They are okay. The main two types of constructors. We have default constructor with no parameters. If no constructor is defined, Java provides a default constructor. We have a parameterized constructor with parameters used to initialize objects with specific values. Okay. Yeah, there's also constructor overloading, defining multiple constructors with different parameters in the same class. Okay. And with that, we also have method overloading. Method overloading allows multiple methods in the same class to have the same name but different parameters. Okay. Yeah, method overloading. It's used to perform similar operations with different inputs. Yeah, we also have access modifiers that control the visibility and accessibility of classes, methods, and variables. There are four of them. We have public, where you can access information from anywhere. We have private, access only within the same class. We have protected, accessible within the same package and subclasses. Okay, the default is a no modifier, basically accessible only within the same package. Yes. So I thought we'd look at Java Swing and Java FX, but I don't think we'll have the time because it's past time right now. Yes. Okay. Thank you. Until next time, have a good one.